Now in this video, we're going to start to talk about series parallel equivalent circuits. Now it's very important before we begin this series of videos on series parallel circuits that we must have a firm and good understanding of when resistors are in series and when resistors are in parallel. So remember, resistors are going to be in series if the current flowing through those resistors are the same. Resistors in parallel are going to have the same voltage. Alright, let's work a few problems to see if we can try to understand what exactly is going on, right? So in this question it says, find the equivalent resistance RAB in the circuit. So they give us this circuit and they want us to find the equivalent resistance, which is going to be RAB, which is the resistance looking through the terminals A and B. So just imagine this RAB wasn't here and we had a source right here. So let's say we had a source. I'm going to make it a voltage source. And normally this is how a circuit that we see would look like, right? It would be a source that looks something similar to this. Now in this particular situation, they don't give us a source. They want us just to find the equivalent resistance of this circuit. So just remember, it's very similar to what we're used to seeing. The only difference is, instead of it being a source, they remove the source and they want us to look from these two terminals, right? So I want you to treat it like this. I want you to treat it as a voltage source plus the minus. So A is going to be positive, B is going to be negative, right? That's kind of how I look at it. And I look at it as current is flowing through it. Even though that's not the case, because it's no source there, that's kind of how I visualize it, right? I visualize that current is flowing this way. Okay, that's how I visualize what's happening with this circuit, even though there isn't any source. Now, a good rule of thumb is to always start furthest away from the terminals that we're looking through. So if we're looking through these terminals, it's best to start on this side over here. Okay? So the first thing we can do is we can just start to redraw this circuit. So I'm going to redraw it now. Now when we look at this side of the circuit, what do we see? We have a 6 kilo ohm resistor, a 3 kilo ohm resistor, and a 2 kilo ohm resistor. Are these resistors in series or parallel? That's a good question, right? Well, let's just redraw this and then we'll talk about it some more. So I'm just going to redraw it really quickly. Now once we get here, right, with this slanted wire, I'm actually just going to draw it as a vertical wire. And because there are no resistors at the bottom, I can just draw the wire at the bottom. Okay, so we started with this diagram here, and I redrew it to look like this. The only thing I did different, as you can see, is I redrew this slanted wire to be a vertical wire, because I think for the most part, it'll be easier for us to solve this circuit if it looks like this. Now, if you're comfortable with solving circuits that look like this, go right ahead. So this is just the first step I'm going to do. Now remember, we're going to start furthest away from the terminals that we're looking at. So if we're looking at these two terminals, A and B, we're going to start on this side of the circuit. Okay? So when we look at this, we have these two resistors. Are they in series or are they in parallel? Well, think about it, right? We know these are going to be in parallel. Now you might be asking the question, why are these two resistors in parallel? So think about it like this, right? We have a current that's coming this way. When this current comes this way, right, it's now going to come through this resistor, and at this node right here, it's actually going to split. So at this node, the current is now going to go this way or this way. So once the current splits, we know therefore that these two resistors must be in parallel. Now the current is going to continue, right? Let me change the color. And as this current continues through the 2 kilo ohm resistor, when it gets to this node right here, it's going to split again. So it's going to go this way and it's going to go that way. Therefore, we can say that these two resistors are going to be in parallel. So this is how we know these two resistors are in parallel. So let's start to simplify this. So because these two resistors are in parallel, we can just say 3 times 6 over 3 plus 6. When we break that down, that's going to give us 18 over 9, which equals 2 kilo ohms. So let's redraw this circuit again. By the way, it's going to be plenty of redrawing when we're doing circuits like this. So we just redrew the diagram and we simplified these two resistors that were in parallel that gave us 2 kilo ohms. That's where we got this 2 kilo ohm resistor from. Okay, now when we look at this, so now we have this 2 kilo ohm resistor and this 2 kilo ohm resistor. Well, ask yourself, are these resistors in series or parallel? Well, think about it, right? You have a current that's coming this way. This current is just going to flow in this direction here, which means the current in this resistor is the same exact current in this resistor. Therefore, we can say these two resistors are in series. So because these two resistors are in series, we can just add these two resistors. So we have 2 plus 2, which is going to give us 4 kilo ohm. All right, so now let's redraw this once again. So we have, okay, now that we have this, we're going to look at these two resistors. We see these two resistors are going to be in parallel. So when we find the equivalent resistance of these two resistors, we're going to say 4 times 4, 4 plus 4. That's going to give us 2 kilo ohm. So now we can redraw this circuit once again. So it can look like this. We're looking good so far. Now when we look at this circuit, we can see that these two resistors are going to be in series. So because these two resistors are going to be in series, we can now add these resistors and redraw the final circuit. So we're going to have 2 plus 1 is going to give us 3. And we know the units is going to be kilo ohm. So this is going to be our equivalent resistance of this circuit here. So RAB, which is the equivalent resistance, is going to be 3 kilo ohm. So this is how you solve an example like this, right? We took our original circuit diagram and we said, this slanted line might give us some trouble. So we just redrew it as a vertical line. So we started off with this. Then we got this. Now that we drew it as a vertical line, we just started to simplify this circuit. We know these two resistors were in parallel. So we found the equivalent resistance for these two resistors. And we were able to simplify that diagram to look like this. Now that we have this circuit diagram, we notice that these two resistors were in series. So we added these two resistors, and then we redrew the diagram once again, and we got this diagram here. Taking into account that we have a 4 kilo ohm resistor here and a 4 kilo ohm resistor here, and these two are in parallel, we found the equivalent resistance, and that gave us this circuit diagram here. Finally, we noticed that we only had one more step to go, and that was adding these two resistors that were in series to give us our total equivalent resistance looking through the terminals A and B. And that gave us the answer of 3 kilo ohm. Let's do another example. Okay, now this question says, find the equivalent resistance RAB in the circuit. So they want us to find the equivalent resistance looking through the terminals A and B. And these are going to be the terminals A and B right here. We know we're going to start off looking at the resistors furthest away from these terminals, which is going to be on this side here, right? Now when we look at these resistors, we can see that these three resistors are going to be in series, right? We know these three resistors are in series. So when we simplify this, we can say we have 1 plus 1 plus 1, which is going to give us 3 kilo ohm. So when we redraw this circuit for the first time, we can draw it as, so we're going to have 3 kilo ohm, which is going to cover these three resistors here because they're in series, right? Now we're going to have a 2 kilo ohm resistor, which is going to be this one. We have another 2 kilo ohm. We have 2 kilo ohm at the bottom. This resistor is going to be 2 kilo ohm. This one is 2 kilo ohm, and this one is also 2 kilo ohm. Okay, now let's continue to reduce this circuit. We can see we have these two resistors and they're going to be in parallel, right? So because these two resistors are in parallel, we can say 3 times 2 over 3 plus 2. 3 times 2 is going to give us 6. 3 plus 2 is going to give us 5. Therefore, we got the answer 6 over 5, or you can write 1.2. And that's going to be kilo ohm. That's the units. So let's redraw the circuit now. So we have 2 kilo ohm, 2 kilo ohm. We have 2 kilo ohm here. This is going to be 2 kilo ohm, 2 kilo ohm. And we just found the equivalent resistance for these two resistors, which is going to be 1.2 kilo ohm. Okay, let's continue to reduce this circuit. So now we have these three resistors, and we can see these are going to be in series because the current is going to be the same through all three of these resistors. So when we add this, we can say 2 plus 1.2 plus 2 is going to give us 5.2 kilo ohm. So let's now redraw this. We can redraw this as, now that we have this, it's easy for us to see that we can now simplify this even further. These two resistors are going to be in parallel. So let's find the equivalent resistance. We have 2 multiplied by 5.2 over 2 plus 5.2. When you solve for that, that's going to give you 1.444 kilo ohm. So now let's redraw the circuit. And as we can see, all three of these resistors are going to be in series. So when we solve for this, we're going to have 2 plus 1.444 plus 2, which is going to give us 5.444 kilo ohm. So our last circuit diagram, when we redraw it, it's going to look like this. Therefore, we can say the resistance, looking through the terminals A and B, is going to equal 5.44 kilo ohm. This is going to be your answer. And of course, I rounded it to 2 decimal places. So this is how you're going to solve problems like this. It's not hard, but it's definitely going to be a lot of redrawing, and you must be able to know when resistors are in series and when resistors are in parallel. Let's do one more example. Now for this example, I'm not going to spend as much time redrawing the circuits, but we are going to talk about each step as we go along, right? So when we look at this, we have this circuit, and we know this is the terminals they want us to look through, right? So as we stand through this, just imagine the current is going this way, right? This is the positive terminal, this is the negative terminal. So we know the current's going this way. So we're going to start at the opposite end of the circuit, right? Most times. Now when we look at this, we have 2 resistors and they're going to be in series, right? We have a 2 plus 2, that's going to give us 4 kilo ohm. So when we draw this circuit now, we have 4 kilo ohm, 4 kilo ohm, 2 kilo ohm, 12 kilo ohm, and 9 kilo ohm. I'm sorry about my drawing, but that's what we're going to have for now, right? So we have this. Now you might be wondering, what do we do from here, right? Well, notice, even though this resistor is not on the vertical line, we know these 2 resistors are still in parallel, right? Because we know there's going to be a current flowing through here. And once it reaches this node, it's going to split in this direction and in this direction, which means that these 2 resistors are going to have different currents coming from, and because the current that these 2 resistors received came from the same node, we know that these 2 resistors are actually in parallel. So when we take the parallel equivalent resistance for these 2 resistors, we're going to have 4 times 4 over 4 plus 4. That's going to give us 2 kilo ohm. So let's redraw this circuit once again. Remember, this is terminal A, this is terminal B. And we know that this resistor is going to be the equivalent of these 2 resistors that are in parallel, which is 2 kilo ohm. Now when we look at this, we can see that these 2 resistors are in series, so we can redraw this to be 9 kilo ohm, 12 kilo ohm, and this is going to be 4 kilo ohm. Okay, now when we look at this, we know these 2 are in parallel, because once the current comes to this node, it's going to split and come this way and this way. These 2 resistors are going to have to be in parallel. So we're going to say 12 times 4, 12 plus 4. That's going to give us 3 kilo ohm. So when we redraw this once again, we're going to get a circuit that looks like this. We're going to have AB. This is going to be 9 kilo ohm and 3 kilo ohm. And we know these 2 resistors are going to be in series, so we can add them to 9 plus 3 is going to give us 12. So our final circuit for the equivalent resistance looking through terminals A and B is going to be 12 kilo ohm. So our answer for this problem equals to 12 kilo ohm. So this is how you solve these types of problems. It's a lot of redrawing, that's for sure, right? You have to be able to redraw these problems. So it takes some time, but it's not a hard concept all in all. You just must be able to understand when resistors are in series and when resistors are in parallel.